Thank you, Amit, for the excellent talk. Leveraging different resource demand patterns between real-time and batch workloads is a great insight for resource management. Facebook also sees similar opportunities. Some workloads strictly follow user patterns, some workloads are more elastic. Our last talk today is from Ariel Raw. She will talk about how Facebook improved fleet utilization significantly by dynamically leasing spare capacities. Let's welcome Ariel.
Hello everyone, my name is Ariel Rao. I have been an engineer with our Facebook Capacity Engineering and Analysis group for the past 5 years, working on evolving our capacity management ecosystem. Today I'll be talking about Optimus, which is our platform for dynamic resource sharing through leasing spare capacity that's available within our fleet. This has been one of our main strategies for improving the utilization across all of our fleet's resources, and I'll be diving into exactly how we've evolved to the system that we have today. Before actually getting into the technical nitty-gritty of Optimus, I wanted to paint a picture of how Facebook has been thinking about the evolution of our products and services. A few years back, we had published this roadmap for the next 3, 5, and 10 years for where we see Facebook. And it started out with our family of applications around Facebook, Messenger, Instagram, and WhatsApp, evolving into effectively an ecosystem of products and really looking forward into the next 10 years of transforming how people stay connected online. This is through virtual reality, augmented reality, AI, as well as our connectivity technologies. The roadmap that we have here really requires fast-moving infrastructure that can scale up as quickly as the vision for our products. And so Facebook has invested into building our own cloud infrastructure and our infrastructure as a service initiative that we had announced at a previous @scale in 2018 is one of the testaments to that. When I talk about cloud infrastructure, I wanted to call out that there are multiple different dimensions that we're thinking of. There is, of course, the server capacity that is running those resources. Power, network, cooling, and space are all peripheral dimensions that we need to think about in order to make that server capacity useful. For today, I will be focusing on that server capacity. Just know that all of these other dimensions are considered each time we think about our planning and usage of our infrastructure. Now, when we get to understanding how our infrastructure scales up, I wanted to start with a simple visual over the time scale of a few months for how we project and plan out our future growth. We start out by taking a look at the current capacity that we're using to support our products and services, and we can take a look at growth rates and product launches coming up to get an estimate of how much additional capacity we'll need in the coming months. However, it's actually important not just to have sufficient capacity for our services, but also to maintain that capacity availability with a certain SLA or a certain expectation of reliability. And the way we build this resilience at the infrastructure level is actually having a layer of additional buffer resources in case any of the capacity becomes unavailable. What we see is that with that higher curve of additional capacity resources, it enables us to have a buffer of spare resources to pull in and use at our discretion. This spare capacity is also used to mitigate any unforeseen circumstances that may come up. So one example of that, for anyone who's based in the US, you may recall that in the past few months last year, we had a number of different wildfires on the West Coast in California and Oregon. Over the winter, we also had high chills in Texas. And all of these different environmental factors actually potentially impact our physical data centers as well in terms of making capacity unavailable. So the buffers that we have really build that redundancy and make sure that we can keep our site online and our users connected regardless of what happens. Now, the curve I had talked about earlier was sort of very simple, our current capacity and the projection upward. But the reality is that capacity management and capacity requirements are not linear. whenever we launch a brand new product or a brand new engagement campaign, it will increase the amount of capacity we require around that time of the launch. At the same time, our physical infrastructure doesn't scale linearly either. Whenever we break ground on a new data center or get a new shipment of capacity within our sites, that will also shoot up the supply of capacity that we have. And so just like before, where we had planned a certain amount of buffer capacity will also organically show up within our fleet, just as a function of how we do capacity planning and distribution. So all of that is within the course of a few months, but what's interesting for Facebook is we actually have variation in capacity usage just in the period of one day. So if we take that time frame of a single day and take a look at the amount of capacity we set aside for our services, we can actually recognize that the amount of capacity we need hour over hour will change as well. And this is really because a significant portion of the capacity on our site is supporting user traffic. And with a global user base, there are different hours of the day where there are more users on our site and other hours of the day where perhaps some of our users are asleep. What ends up happening is that there are variable amounts of spare capacity within our site just throughout the period of one day. When we put all of it together, taking a look at the spare capacity within a day, as well as the spare capacity through our data center operations, as well as the buffer for infrastructure resilience and reliability, we see that there are a number of different sources for spare capacity that, if left on its own, would remain idle and is not a very efficient use of resources at our scale. And so this really leads us to how we've been thinking about leasing capacity and identifying alternate uses for that spare capacity for the duration that they are spare. Now, what's interesting is when we first looked at this problem statement back in 2013, we had a highly fragmented cloud infrastructure. We had different pockets of spare capacity that were given to different teams, managed in entirely different capacity management stacks, and without standard protocols of capacity allocation and distribution. And so even if we could identify a large quantity of spare capacity, it was very challenging to lease to other teams and make that capacity resource available for additional secondary uses. And so in 2013, it was quite challenging. Now, in 2015, we took another look at this problem and said, hey, there is this big bucket of unreserved capacity from infrastructure operations, right? This is when we turn up new data centers. This is the buffers for infra resilience and reliability. And we said, hey, let's lease it out temporarily. And as long as that capacity is not needed for infrastructure, we can loan it out to other services to use. And whenever that capacity is needed back, we'll just make sure that we can reclaim it sufficiently and promptly, such that infrastructure operations are not blocked. And so with that problem statement in mind, we came up with quite a simple setup for leasing capacity. And this is that Optimus system. First component is a resource broker. The primary responsibility of the resource broker is to identify any server that is unreserved and spare and attribute it as eligible to be leased out. The second component we think about is how do we keep track of all of the different services and teams that have request capacity to be leased. So our reservation system holds all of the metadata of the quantity of capacity requested, the duration of the lease, etc. Now, what combines these two components together is a resource allocator that says, hey, these are all of the services and servers that are available within our resource broker, and these are all of the teams that have requested capacity. The resource allocator does that allocation of resources to leases. And finally, we have a workload deployment stack, which allows teams to deploy their workloads and services onto the capacity that we have made available. With this setup, it's been critically important for us to set clear expectations on what it means to lease out spare capacity. We have to keep in mind that even though the capacity resources are currently spare, they have been purchased by other teams for other operations. And so whenever that original owner of the capacity needs the resources back, we need to be able to promptly return it. And there is a production risk if we don't do that. So with those capacity expectations in mind, what we set up was what we internally called zero SLA capacity model. Because of the way our spare supply pool behaves with fluctuations on availability due to planned as well as unplanned events, what that meant was we couldn't provide any guarantees on the total amount of capacity that would be available at any time. And on top of that, because the capacity had an original owner, whenever that original owner needed the capacity back, we would have to be able to quickly and promptly return that capacity. So there's no grace period that we can provide to extend a lease once that capacity needs to be reclaimed. Now, this capacity model may sound terribly restrictive, but we have actually had quite a bit of success finding customers to use these resources. And I'll dive into one around online ranking. Now, when you think about what happens when you open up your newsfeed at Facebook, what we're doing is we're taking a look at a candidate set of stories and posts to show you. When we do this ranking, we take a look at a top N set of candidate posts and identify which ones to show at the top of the feed. Now, what we can do with additional capacity is look at more candidate posts. Each time we add additional capacity resources to our online ranking services, they can look through more candidate posts and find higher quality results to show on your site. And so it looks a little bit like this. There is a static latency target that we hit for services to identify the stories to show and the posts to show. And as we add more capacity, we can get higher quality results and improve the engagement on our site. Whenever that capacity is not available or reclaimed, we simply look at fewer candidates when showing the content on the site. And so we are still able to hit the latency expectation and provide a high quality experience to our users with a variable amount of capacity that comes and goes whenever supply is available. Even though we mentioned that we cannot provide any guarantees around capacity availability, the actual stability observed of the spare pool is quite stable. And this is because we don't have unplanned or major operations happening every day of the week. And so what's absolutely important for us to be able to do as an infrastructure team is to be able to validate that services can handle the zero SLA model as intended. To do this, we periodically reclaim capacity from services and from our infrastructure pool, even though those resources are technically available. And this allows us to ensure that services are able to gracefully handle the capacity changes from reclaims, as well as validate that our infrastructure can quickly execute on capacity reclaims whenever that intent to reclaim is issued. Now, beyond online ranking, I wanted to talk about one additional workload that we've had great success supporting, and this is large-scale offline video generation. If you've ever gone on Facebook around New Year's Eve or on Friends Day, you'll see a customized video that Facebook generates with you, as well as all of the content that you have shared in the past year. What we do is for each of our over 2 billion users, we generate customized videos with their content right before the launch of that day, such as right before New Year's Eve. Now, if you think about this, New Year's Eve happens at the same time for everyone around the world, plus or minus a few hours. In order to generate this content with the freshest data and the freshest sort of content that people have shared on the site, we need to do it in the days leading up to the launch of these videos, and we cannot do it too far in advance. This requires an exorbitant amount of capacity for a very short period, and once the videos are launched, that capacity is no longer needed. What we've been able to do, rather than purchasing dedicated capacity for these short-lived workloads, is actually lease out that spare capacity that naturally exists within our infrastructure to support these workloads. Now, you may be thinking, hey, there's zero SLA for capacity availability on Optimus, but videos need to be generated before New Year's Eve. How does that work? And you're absolutely right. Our zero SLA model is not a perfect fit for these workloads because there is an expectation that all of the computation happens before the launch. However, because we are so closely tied with our infrastructure, for the past few years, we've been working closely with our infrastructure teams to maintain that spare capacity availability and coordinate the timing of infrastructure operations to be able to handle this type of workload. Now, what that takes us to is how we've evolved Optimus from that 2015 model into what we offer today. And so, very explicitly, parts of the reason why we've invested in evolving Optimus is because our spare pool and the management of that capacity has improved and standardized over time. There are additional sources of spare capacity beyond what I had called out at the start of our Optimus journey that are now available to us. And realistically, we can provide stronger availability guarantees than that zero SLA model that we had been operating under. And so this is what our fleet looks like today. Rather than having as much fragmentation as we had back in 2013 and 2015, we've been able to move our capacity management onto a relatively standard platform, making it much easier to move resources from one use case to another dynamically, consistently, and with ease. This allows us to expand how we access the spare pool within our fleet and make it available to various different workloads. On top of that, we had previously talked about various different sources of spare capacity, be it traffic pattern driven use cases or infrastructure operations. Now, when we had looked at the availability of spares in that sort of fragmented world, we saw that different services have different usage patterns, and you can have various services that are not very predictable at all in terms of how they grow, and it's very challenging to reason about. But with our standardized infrastructure now, we no longer need to look at individual services at the granularity that we had previously. And instead, when we look at the capacity as an aggregate source of spares, we actually see that it is relatively stable at this aggregate view. It does not change drastically day to day and is much more predictable in terms of how much supply is available within the spare pool. With that insight, that aggregate capacity of a consolidated spare pool is much more stable. What we've been able to do is pull together signals from one, the historical supply of spare availability, as well as two, the supply characteristics of individual contributors to the spare pool, and ultimately three, the future capacity plans for that spare capacity from the original owners of the resources, and really generate this holistic supply model of how much capacity we anticipate to be available for leasing going into the future. We can actually generate multiple signals of various probabilistic confidences for how much capacity we expect to be available, and in turn translate that into probabilistic guarantees on available capacity for leasing. And what that has allowed us to do is actually unlock use cases for Optimus leased capacity that is more than just opportunistic. So in the case of online ranking, where additional resources enables a higher quality result, but lack of resources does not have any production impact, what we're able to do is also take a look at time shifting of compute for delayable but not optional workloads. So in this image, you can see that a certain amount of capacity is set aside for our traffic serving workloads, and a separate portion of capacity is planned for our async batch workloads. Now, what we can actually do is delay and coordinate the scheduling of those batch workloads into times of the day where our traffic serving workloads are not using those resources, and ultimately have higher utilization of the capacity in total. Now, the key here is that those async batch workloads are delayable in terms of when they're scheduled, but they cannot be delayed indefinitely, and they still have expectations of when they need to be completed in order for the product to move forward. And so, diving into a little bit of what it looks like to request such time-shared capacity, the first major change that we are thinking of is capacity in terms of compute hours. This is a characterization of the amount of work that a particular workload needs, rather than a static amount of capacity resources that are set aside. The second component of this is explicitly capturing the extent to which a workload can be delayed. Does it need to be computed once a day, once a week, once a month, or at any other custom cadence? And finally, capturing exactly how tolerant that workload is to preemption and movement across supply. Where we come away with is a lease plan that looks a little bit like this, where during various hours of the day, there will be different amounts of supply made available to the workload, but at the end of each allocation period, be it a day or a week, the total amount of compute that the services expect are available in aggregate. And so, with that capacity model in mind, what we've been able to do is actually, with relative ease, extend the infrastructure that we previously had. We have the same resource broker and reservation management system as before, capturing the new intent that our system is able to sort of support. But we've added the supply modeling component, which is really what we leverage to be able to understand the supply forecast into the future and plan ahead for how to allocate and share the resources over different periods of time. The second component that we have adjusted is actually taking that single allocation engine, which would do just-in-time alignment of resources with leases previously, and split that into two components. The first one pulls in that supply signal to understand not just how supply changes over time for that spare capacity, but also how the demand and for how the leases have different preferences and requirements and expectations for capacity availability. And from that, generate an intent plan for how to schedule workloads over the sort of future timescale. And finally, as before, an allocation engine, which then takes that future plan and that time series of allocations and does the alignment with actual spares available in our site. With this expanded architecture, we've been able to unlock that time shift compute workload that I had mentioned earlier, but I wanted to touch a little bit upon the value that we get simply by standardizing the capacity leasing infrastructure that we have. For most of the people in the audience, you'll have recognized that the past few months with COVID have been taxing. Many people are staying at home and turning to online resources for staying connected with families and loved ones. What we saw at around March 2020 was that the group call time in Italy shot up beyond the levels that we had seen previously. What we've been able to do with the leased capacity model is quickly mobilize large amounts of resources for the products and services that are seeing increased traffic and make that available as quickly as possible. We have also been able to rearrange and sort of redistribute capacity available to AI research programs, experimentation, product launches, and mobilize our capacity fleet for the services that need them the most. And this is all coming about because of our standardized infrastructure for moving capacity from one use case to another. In total, the number that I wanted to sort of call out is we've been able to increase the overall fleet utilization by over 5% simply by more intelligently scheduling and coordinating the use of our supply in accordance to the workload characteristics that we have within our fleet. Everything that I had talked about so far for how our systems have evolved for dynamic leasing is in production today, but I want to talk about some of the additional ways in which we can evolve our ecosystem to make it more efficient and more usable for our customers. The first to mention is thinking about how our spare pool is managed across the board. Primarily, our spare supply for capacity leasing today is a function of other teams, whether it's infrastructure or products and services, and how they manage their planned capacity. However, as we have seen, because we're able to use this capacity when it is predictable, we can pull in the various signals that these teams have for capacity management and generate higher confidence predictions and estimates for supply availability. This will in turn allow us to unlock additional use cases for predictable supply that is delayable. Now, the second two dimensions here are around the stability of individual resources we allocate to lease owners. Through our supply leasing model, what we're able to do is move resources in and out of various leases as they become available within the spare pool. But on top of that, what we're able to do is think ahead to when particular owners need that capacity back and provide more graceful shutdown and reclaim of capacity as we sort of have signal into future capacity plan. And ultimately, what we want to be able to do is validate that services are able to handle that graceful degradation of capacity availability in the same way for probabilistic capacity availability as I had mentioned previously for that zero SLA capacity model. So all in all, really thinking about how our services can have a more consistent experience on the leased capacity as they do with any other capacity model that they operate on. So with that, I want to thank everyone for joining in today. Thank you.